Right, I'm going to be working on pathfinding. I made a whole video of asking AI for some help with this. I was almost there, but I don't think the logic wasn't really doing it. It was simply checking each of the neighbor tiles and seeing if it was a valid movement position, but it wasn't taking into account the jump height or anything. So yeah, I'm just gonna try following along an explanation of how it works, and then I'll try and code it up as we go. So I've got a bit of starter code here, just some kind of node with a position, G, H, and F cost, what you'd expect, the parent, grid system for deciding if a position is blocked by something that's in the grid system, and a sphere radius for doing an overlap sphere check. So this will come into play later. So let's see. Initialize, set the start nodes G and H using heuristic. Right, so we have the start and we have a goal. Node So I guess we're creating nodes based off the start and end. So I guess this is start node, end node. I don't like goal either. That's start position, end position. So the start node dot G cost is equal to 0. Start node H cost equals Manhattan distance. Okay, we've seen this. Let's just, can you show me the Manhattan distance formula? X2 minus x1, y2 minus y1. Okay. Private, is it float? Float or an int? What's H cost? Float, right. Private float. I wonder if this is already a thing. If I do vector3 dot distance. Yeah, maybe I can just pop in the node though, Manhattan distance, and then do node X and node Y, and then return to be Y. Okay, this is not a good naming. Nodes A and B, so it'll be A B position X minus A position X plus B position Y minus A position Y. But this is not just 2D. Is this useful for 3D? Yeah, I would assume, yeah, you just tack it on. B dot position dot Z minus A dot position dot Z. Okay. So H cost equals Manhattan distance between start node and end node. Compute if G star, oh F, yeah, F cost is already a value, right? Yeah, G plus H, okay, we don't need to set that. So there's an open list and a closed list. Open node list equals that, and then closed node list um, open node list, okay, while the open node list count is greater than 0. Node current node equals open node list, get the first one, open node list dot remove at 0, close node list add. Okay, so I guess if the current node is the goal, if current node dot position equals end position, completed. Reconstructed layer. A list of vector 3 ints equals reconstruct. Okay, so I need to add reconstruct code. And then final node, or I guess node is fine. It's only one we're interested in. No, end node just to be clear. Start at the goal and follow the parent pointers back as we grab a list. Okay. path equals that. So we'll add the end node dot position to the path, and then is it while node current node equals end node dot parent. While current node does not equal null, we will add the current node position and then set the current node equal to current node dot parent. And that gives us a back to front list. So yeah, that's where we want to reverse and then return the path. I think that's fine. Let's just see. Start with the end node, add the position to the path, then set the current node equal to the end node's parent. And if that is something, then the path will add that position and then try and set the next parent. And then if it's still not nothing, it will add that position. Okay. Okay. Let's see. Return reconstruct path and then pass in the current node. But if that's not the case, then we will have to remove the first node and add it to the closed node list. And then grab the neighbors. So do we want, there's no point searching up, I don't think, unless up is some kind of hatch, maybe a ladder, but we'll worry about that later. Right now, I just want to check the 4 cardinal directions. So private Vector3 int get neighbor positions positions equals this, and then I will just add them hard coded. So I need to put in the origin position or starting point, I guess. It's going to be origin plus um, maybe I just add it in like that. Alright, so left, right, forward, and back. And then I can just return that rather than catching it. So let's see. For, I guess we want to catch them first. Let's see, and neighbor positions equal get neighbor positions, and then we'll pass in the current node position for I in neighbor positions dot count. So this is looping through each neighbor. Skip if the neighbor is in the closed list or impassable. If closed node list dot contains position, continue. Yeah, we don't really need the nodes, but we do need the nodes. Where are the nodes even being saved or like stored? Um, let's just keep going. Explore the neighbors. So this is them here, but it's not really how I want to be looking. I'm not looping through nodes or anything. I'm looping through positions. Skip if the neighbor. So yeah, here we go. For each neighbor of the current node. So I'm thinking this is maybe expecting a node, i.e. when you use a grid, you know that there is a grid point or a tile or something. Maybe I can just make list of nodes, node list. All of the nodes are going to get added there, but only the positions are going to get added here. So we add the starting node position. Maybe I'll go that. Yeah, because we're fetching them from here. So we node list to add the start node dot position and the start node, and then add that to the list. And then when we loop here, we'll grab the current node from node list and then at that position. So we get rid of that and we add the current node position. I think this is closer to what we want than the last attempt I made. So neighbor positions, get the position. If it's already in a closed list, we continue. That's cool. And then, or if it's impassable. So this is where we see movement is valid, and then we'll pass in the position here. And then we'll just reverse that. So private bool is movement valid. Right now we'll just return true. Okay, so then we calculate the G of the neighbor. Neighbor node. Neighbor node equals new node position. Neighbor node G cost is equal to current node dot G cost plus 1 because we're moving one spot. If the neighbor isn't in the open list, add it with its G, H, and F values. Okay, neighbor node dot H cost equals Manhattan distance. The H cost is the current position to the, well, the distance between the current position and the end node, I believe. So it's current position and end node position. It's maybe one of the nodes here. Okay, and then node list, we need to add it, the neighbor node. And then maybe just create a little safety function. Add to open node list. Add to closed node list. And also remove from open node list. So this just allows me to call this here without worrying about validation, and then in here you worry about validation. So if open, although the open nodes aren't in here. These aren't in the object itself. Maybe they ought to be though. And I just empty it out after use. Okay, let's go private. At the start, node list dot clear, open node list clear, and close node list clear. So every time we run this, these are going to be blank again, getting rid of all the nodes, etc. I should probably run this at the end, which may be cleaner. It means that the garbage isn't hanging around till the next time you use this, it's just gone after you use it. So I'll leave it at the start for now, and hopefully I remember to add it in anytime we return early and at the end. Okay, so now we can do that. If open node list dot contains node dot position return otherwise open node list add node position. Also add node to node list. So remove if open node list dot contains node dot position and reverse it. If it doesn't contain it, quit out early. Otherwise, remove it. If close node list contains that, return, add the position, and then this one, very similar. If the node list dot contains key, that, return, otherwise, add it. Okay, so now we can just do that. Add node to node list, and then start node, and then add node, add to open node list start. Okay, so we've replaced this with that. We've replaced this with that. Now we can do remove from open node list. I wonder if I'll ever use this when it's not removing at 0. Okay, we'll change that for now. Remove from open node list can just be remove first from open node list. And then we'll just check if open node list dot count is less than or equal to 0, return. Otherwise, we remove at 0. And we don't need this there. Remove first from open node list. And then add to closed list node. Okay, add to node list, neighbor node. Now where were we? Okay, add to open node list. So this bit here, if the neighbor isn't in the open list, this makes it a lot cleaner just to read down the line and see what it's trying to do without having to see, is this already in the open list? Do we want to add it? Although there's more code, if the neighbor is already in the open list and this new G neighbor is lower, update G, so the G is Cost from the start node to the current node. Actual distance traveled so far. Ah, so this keeps adding 1 to the current G. So where it adds 1 here, it just keeps adding. Oh, okay. If the neighbor isn't in the open list, okay, maybe all this is rubbish since we may need to add more anyway. If the neighbor is already in it, okay, so if he's already, oh, and this new G neighbor is lower. Updated G. So how would we tell this node? Existing node equals open node list. No, it would be node list at node position. This is existing node. If existing node G is lower than node.g, no, if other way around. If the existing G is greater than the current G, existing node G cost equals the node's G cost. The H stays the same and the F automatically changes. Okay, I think that's what it wants me to do. Grab the existing node that's already in here. And then if the G cost is greater than this, that means it took longer to move there. And parent. Oh, I don't think I added a parent before, did I? So parent would be current node. Okay, I may want to just take this back out here. Or just add it here. Is that it? Is that really it? And then add in the current node to be the parent. So that looks through the neighbors. Hey, How does it know how far to go? How long to go for? Oh, it doesn't. It just goes until it hits the end position. Jump height's not included yet. The parent of this will be null. If the neighbor isn't in the open list, set those values, which we did, but we did not set the parent. Okay. So if we never, so then we need to do the check again, right? Um, if the open list empties before reaching the goal, so for each of the neighbor positions, we'll need to put this in again. I'm not sure exactly where to put this. If I put it in here, that's cutting off a potential fastest path, right? If I put it out of here, that means it checks all the neighbors and then checks to see. No, no. Oh, hold on. I've already got that inside the loop, so that's fine. This this is probably fine. Okay, so reconstruct the path, which we did add somewhere. hmm but we can just return a new slash empty. So nothing was passed. No path is possible. We've got no path. So let's just get some kind of visual. If I click on, okay, this isn't going to work yet. But this part may. Instead of setting the position, it should find the path between where we are and where we want to go. So I think only this is the part that's different. Pathfinding. Oh, it's battle.path. Find path. The acting unit. Okay, current position. I want to go to new position, and jump height doesn't matter right now. Uh, path equals. So we will maybe keep that in, but for each waypoint, I guess, in the path, this is where we'll create our little sphere object. It's going to be path I. So if I click somewhere, it should draw the path that it wants to take and also move the character there. So let's just give it a try. I've not tested yet today. So if I click here, nice. If I click here, okay, it needs to clear. But this is looking pretty good. Just on a 2D grid right now. Yep. Oh, it's kind of broken. What have I done? Okay, I've managed to crash the editor. Okay, we're back. And it seems like it's fine again. Maybe I clicked too quick and some code just messed up. Because it does seem like it's fine and it works. Let's see, sort of taking a path that it thinks is the quickest. So I'm happy. So then the next stage is using the A star to find positions within a movement range. Well, first of all, maybe I'll work on what's valid and what's not. And what happens if I click on one of these actually? That's exactly what causes the crash. I click on something that's on a higher level and it breaks. So that's obviously something I've messed up in the code. And back again. So I've commented out the pathfinding line, so I can still move around, but let's see if it breaks again when I click on a hill. No, no, he moves quite fine. Hmm. Yeah, I'll need to find out if there's some nice way of detecting the piece of land rather than if I click here, it's going to throw me on one of the multiples of 0.25, which is obviously not good. Yeah, so okay. So I know that the pathfinding part is what's broken, which is fairly expected. While the count is greater than 0. each neighbor is checked if it's closed, added to the node list, added to the open list. Once it comes back around, we take it out of the open list, add it to the closed list. Is there ever a way that this is what causes the infinite loop? Um, and we'll also add a little counter here. While that's greater than that, and counter is lower than 5,000, say. So it should break out of a loop if this is the one that's causing the problem. Surely can't be that, because a lot of these nodes will have null as the parent. Alright, let's just try again. If I need to keep closing this beast down and starting up again, that's fine. I'm not actually running it. Cool. Let's go again. Here we go. So that's fine. That's fine. Is this fine? 202. Wrong thing, wrong thing. So it's in here. Maybe this. If it's already closed, continue. If it's not valid, just continue. Maybe it should be, if it's not valid, set it to closed. So why, hold on. Starts off with the 1, jumps up to 4 neighbors, then it becomes 6. Because it checks 1, bringing it down to 3, but then it adds 3 more. But then it checks 1. Okay, so steady increase. There's a lot of things to be checking. Drops down to 8. Oh no, this must have been me starting again. Okay. and it just rises and rises. And gets stuck on 202. Oh, it must be because it's not finding. Um, it doesn't know how to go up a step to get to 1 on the Y. So because it can't ever land on its goal, it just forever expands. That must be what's happening. Okay. Um, okay, so let's add in if something's valid or not. We're going to throw a lot of checks and try and say, well, that makes it false. And if it passes all of those checks, then we know it's true and it is valid. So the first one is going to be the grid system. Let's check the grid system. If a grid object does exist, then we'll just grab that grid object. If grid object dot, if it's not empty, the grid object technically shouldn't exist if it's empty, but we'll throw in that check. If the grid object does exist and it's not empty, return false because we shouldn't be here. We shouldn't allow them to land here. That's the first check I'm going to do. So now these 3 spots, the character should try and walk around them. So let's stand here. Let's try and walk through them. So why don't we want to do the balls anymore? Am I breaking out too quick and it's causing an error? It's just escaping and returning nothing. That might be it. Maybe this is expected behavior. Oh, he's done it again. Okay, I was getting a lot of problems. So I just copy and pasted my code into Grok and asked it what's going on. And here's a couple of things that seem to have been either left out or I just didn't read them correctly. I'm always picking the first node. It says A star requires selecting the node with the lowest F cost. So I need to, at the start, I should take the open node list, order line Q, where are you? Using system dot or link, whatever it is, the order by, yep, lowest is best, so then it'll be n dot f cost. Node list n f cost. And then I will do to list and then set the open node list equal to that. So now we are sorting by the F cost. So that's fine. That may be it, but also it says the Manhattan distance is supposed to be an absolute. So this should be wrapped in mathf absolute. So the point of this is, if you just do it the way I did it, sometimes it would come out to minus numbers as it says here. So it could think the distance is -7, whereas you don't care about minus. All you care about is the distance, which would just be 7. Oh, it seems like I typed in my typed in my sort of protection wrong the second time. So it should be when it's less than, because we want it to run while the counter is below this number. Okay. That was just a silly error. Node updating logic. When a node is already in, you update its gcost and parent if the gcost is lower, but you don't ensure the list reflects this change in priority. Okay, so I've sorted it now, so maybe that's fine now. Okay. So check the node list first. So the problem with that is if I'm supposed to try adding it and then updating the one that exists, would I not just be I would have to check what the potential G cost could be for a node before. No, I think that's fine for now. Okay, don't get out of here. Let's just try with the counter in place and see if it works, see if it shows the little sphere balls on the ground, or if it's just going to crash again. So if I click and then I click to move, it's crashed again! Even with the protection? Wow. Okay, the protection did save it, but my god, it took a long time. Huh. That's with sorting it. That didn't seem to fix the problem. That's disappointing. Let's try asking again. My code. Can you now check what is wrong? Still issues which can cause inefficiency and correct behavior, hence the need for that check. Oh, crap, I only did that. Ah, okay. Silly me. Now it's on all of them. Cool. Incorrect F cost. So hopefully, I'm hoping that's it, but we shall see. Use a priority queue instead of sorting repeatedly. Alternatively, sort once when adding nodes. Oh, okay. Sort when adding nodes. So if this adds, say, 4 nodes, you want to update the list every 4 times you add to the list, as opposed to once right before grabbing. I guess it could save if it decides there's no reason to add any more nodes and it's just going through the list and removing them rather than adding them. Maybe then it would become quicker. But this is fine for now, especially for testing. After sorting open node list by fcost, you remove the first element with however, in add to open list, you don't re-add the node to the list if its gcost is updated. So if the open list already contains a position, you don't re-add it. Well, it's already in. Only its value and so you want me to update it. But that's just okay, so maybe it's one of the neighbors. One of the neighbors. Let's just rip that out of there then. If something is added, we'll add it to the bottom and let's see what it says. Right, let's go. It's not wrong, but it's not necessary because they're never revisited anyway. Okay, so is that I'm not adding them to the list so it stops checking them. Okay, that's fine, that makes sense. Get rid of it. Alright, let's spit it in. Let's see. It's still gonna have some problems with certain parts, but suboptimal inefficiencies, suboptimal paths are need for that. Okay, what do you say then? Let's just copy. What does it say? That's what I had. What the fuck? Well, no, I've not got the node here. Why? But I wouldn't I wouldn't need this if I was just using that. Sort only once per iteration. You just told me you didn't want that there. Now you say you do. Find path. Tentative G cost. Neighbor. Let's just see. I think that means it's returning nothing. Undo, undo. Get it in the top again. Why does it find nothing? Okay, I came up with something pretty cool. Top face mesh generator. So, disclaimer, I did just ask Grog to create this, but I came up with the idea, so that's what counts, okay? Um, so what it does, I said I only want the top face of this mesh to have a collider on it. And that's exactly what it does. So now it won't think anything underground is a valid position. See, only the top faces have a collider. So now if I click and then move this out of the way, it doesn't create all those fucking balls everywhere. Only the valid ones. So this character, I believe, is the thief, which can jump quite high. So 1, 2, 3, 4. If I swap to someone else, I think this one is the mage type person. They can't even get up here. They can't get up there at all because the jump is low. So that's really good to see that finally made progress. Took a long time. Took a lot of trial and error, a lot of AI, and yeah, I think it's almost done. So instead of creating these little balls, I'm going to create a movement sort of marker, and then maybe just have it so if the player clicks on a valid position that's where one of these balls are at the moment, then it's okay. They can move there and just do the movement. Um, I do still need to add in some code to block these off properly. That doesn't seem to be happening yet. So let's check it out. Yeah, this I don't think I'd be able to write this code on my own at the moment. A lot of vertices work, triangles, normals. I did a tiny bit of this before when trying to follow along a Minecraft tutorial on sort of building your own Minecraft, and that had a lot of this sort of vertex work or vertices. But yeah, this is just an idea, and that's the power of AI. That if you have an idea, you're not quite sure how to make it work yourself, you can get some help, and you can still create something that you want based off of your idea. So let's see, where's the breaking part? Can move to position. So if an object does exist at this position, get the grid object. If the object is not empty, return false. So these positions should be false, but I think it does create a little ball underneath. So let's move that battle unit. Oh, no it didn't. Okay. Problem solved. So 1, 2, 3, 4. Yeah, okay, 1, 2, 3, 4. It is working, nice. So the purpose of this is so I can have multiple layers. So I will try and create something in Blender that has an extra layer, maybe over here, and I want to still be able to move underneath, but also be able to get on top. So be right back. Yeah, I may as well record this part as well. So here we go. So I'm just going to move this up here. Let's bring it down a bit. So let's just make it 1. 1's far too big. 0.25. Um, that's a really strange. Okay, much better. 3. It's just a little lookout nest thing. And maybe bring it out a little bit as well. So I'll probably delete this if I want to actually make this a level, because this is horrible, the way it just sticks out. You know, maybe if it's only 2, or even 1, and maybe if this top bit is 1 as well, that's part of the walkway. Nah, it's fine. I'll just keep building on it for now. So let's bring this up by quite a bit. So that's not in line with anything, so I think that would do it. Yep. So if this comes up as well, now I wonder if this means that the thief can get up here, because he goes 1 step, 1 step. I think that's 4 steps, 4 steps, and then 2 steps to get up here. And this is a upward facing platform. So let's just save. Oh, I took the wrong thing. So put the wood on there. I think I need to put the script on here. Top face mesh generator. And then maybe that'll just work. Maybe that'll work already. Let's go. Let's give it a go. So let's just go here. Wow. Looks like it would work. So hop, hop, and then up. Great. This is exactly what I wanted. So now we can have multiple levels. Someone could be standing underneath, and it should work just fine. Brilliant. Maybe though, maybe the camera is too much. Maybe the 32 is maybe a better angle so you can see more of what's going on. Oh, I'm so happy I finally got this working. But now, so let's go back to 0. Oh, wrong thing. Get away. Let's put this back to 0 and 0. So I believe this is what we should be focusing on. And because we've tilted the camera, it's a little bit not in this, not in, I guess not in the center of where I would like it to be. I don't want it to be completely centered, like that's maybe not showing enough above. So maybe 5, maybe 4. Maybe 4 is good, having it actually in the center. And then let's see if I start moving the camera around, move that to 3, move that to 2. Yeah, that's fine. 0, 1, 2, 3, 0, 1, 2. Okay, just for the sake of it, let's get rid of this. Let's bring that back down. -2. And that's probably fine. That allows someone with a good amount of jump to just jump over. Okay, that's fine. I may as well end this video here since I think that's kind of... No, no, actually. not quite finished this part if I want to cap it off. Uh, yeah, no. Yeah, I'm going to end it.